So here's a second in-class problem we had the other day. It starts off with Bob, who has a mass of 75 kilograms, can throw a 500-gram rock with a speed of 30 meters per second. The distance through which his hand moves as he accelerates the rock forward from rest until he releases it is 1 meter. Part A, what constant force must Bob exert on the rock to throw it with this speed? Part B, if Bob is standing on frictionless ice, what is his recoil speed after releasing the rock? All right, so we've got a couple questions here. I've written all our givens here because there's quite a few, so I did it ahead of time, and I drew our free body diagram. All right, so we've got the normal force, which is the hand supporting the rock going up, which is supporting the weight of the rock, and then the only force acting on the rock, which is causing it to accelerate, is the force of Bob. So if we're going to find out how much force Bob has to apply in order to get it from 0 meters per second up to 30, we're going to start with Newton's second law, which is F equals ma, and we're going to look in the x direction because that's where that force is being applied. So if we do it that way, we've got that the force of Bob is equal to m times a sub x. We need to find that force of Bob, and we know the mass of the rock, so that works out, but we don't know the acceleration. So we need to find that. Luckily for us, they give us enough information to do that. So when they give us these two speeds, right, v sub f and v sub I, and they give us a distance, and I need that acceleration, it tells me that I should probably use the equation v sub f squared minus v sub o squared equals 2ad. All right, so we've got 30 squared minus 0 squared is equal to 2 times a times 1, which is the distance that the force is going to be applied, or how long it's going to take to get from 0 to 30. So we've got then 900 is equal to 2a, or a is going to be 450 meters per second squared. So that's quite a bit of acceleration. Plopping that into what we know then, we've got the mass of the rock is 0.5, and it's going to accelerate to 450 meters per second squared. So Bob is then applying a force of 225 newtons on the rock. So a pretty good amount of force to get it to move. So part B now asks us to find out what is Bob's recoil speed. All right, so how fast is he going to move in the opposite direction because of the force that he applied on the rock? And by Newton's third law, the rock is then going to be applied onto him. So what we've got here is the start of our problem, where we're going to go with part B right here. And to find that force, the sum of the forces in the MA equals MA. Again, he applies 225 newtons, so the rock's going to apply 225 back on him. Right, and he has a mass of 75 kilograms. So we know that his acceleration then is equal to 3 meters per second squared. So that's how much his speed is going to change, or the rate at which his speed is going to change, because of his the rock pushing back on him. The next thing we need to know, if we're going to find his speed, is we're going to need to know the time that he gets pushed on, because really any equation that we have that deals with how much his speed is going to change, or how much he's going to speed up to, is based on how long that force is going to be applied on him. So in order to do that, we need to go to this equation where we've got x equals x sub o plus v sub o t plus 1/2 a t squared. So we have the distance with which he's going to move, or the rock is going to move, is equal to 1. So we're looking at the rock here, because the time that he exerts a force on the rock is also the time that the rock exerts a force on him. So the rock's going to move 1 meter while he applies a force to it. we've got x sub o is equal to 0. Now he starts from rest, so v sub o times t will be 0. And we're left with 1/2 times the acceleration of the rock, and then times t squared. So if we do this out, we find that the time that it takes while he's in contact with the rock to move it 1 meter is going to be 0.0667 seconds. All right, so he's going to push the rock for 0.0667 seconds. The rock's going to push on him for 0.0667 seconds. So now we've got all the information. We have the acceleration, we have the time, so we're good to go in terms of finding out what is his recoil speed going to be. So we know that the velocity is equal to the acceleration times the time. He's going to accelerate by a rate of 3 meters per second squared, and it's going to happen for 0.0667 seconds. So his recoil speed when he throws the rock is going to be 0.2 meters per second. And there you go. That is the second problem.